Hello guy. Today we're gonna do some applications on the logarithm functions. We got here some example. We got log base 5 of 125 equal to x. Remember we said before, what is it when we try to compute log base b of a number? So log base 5 of 125 is like we are just asking ourselves a questions. The question that we're just asking ourselves a questions. The question is like to what power do I? That means the question is to what power do I need to raise 5? So the answer is x. To what power do I need to raise 5? Excuse me, here it's x. Okay, 5 to the power of x equal 125. Okay, that's another way to write the same thing. So here we're just gonna guess, but remember, sometimes it can be hard to find this answer in your head. That's why we may use some calculator to find it. But here we can guess, since we know 5 times 5 is 25 and 5 times 25 is 125. So here we guess that x equal 3. So the answer is 3. So here we got x equal 3. So remember, this is like a question. We ask it, to what power do I need to raise the base in order to get 125? So the answer is like 3. So here what we got here, the base is 3. So the same, to what power? The same is true. To what power? The answer is x. To what power do I need to raise 3, the base, in order to get 1 over 81? Okay, so how we're gonna do, we're just gonna make a conversation here. What we know about 1 over 81, we're gonna work with it. Let's go somewhere else. So I'm gonna rewrite this. I'm gonna rewrite it here. Follow me. If I have 3 over x equal 1 over 81. So what we get, we can rewrite this like 3 to the power of x equal 1 over 3 to the power of 4. Why? Because we know 3 times 3 is 9, 3 times 9 is 27, 3 times 27 is 81. So that's the same thing. We can write it another way, 3 to the power of x equal, if we have 1 over a to the power of n, this can be written like 3 to the power of minus 4. There we go. So we have our power x. By comparison, we know we can say here x equal minus 4. Minus 4. We find it. Remember what we were trying to figure out, to what power do I need to raise. So we were trying to figure out to what power do I need to raise 3 in order to get 1 over 81. So the problem is was log base 3 of 1 over 81. So we try to write in another way, to what power do I need to raise 3 in order to have 1 over 81. Okay, the same thing here. The base is 5. So log base 5 of 1, I'm asking myself, to what power do I need to raise the base, so the power is unknown, in order to get 1. So this can be easy. If I want whatever the base, to have 1, the power should be 0, since 5 to the power of 0 equal 1. So it's easy to say here x equal 0. Okay, what about this one? Just a moment. What about this one? To what power log base 5, 5 square root of 5? Oh, the same questions. Since the base is 5, I'm gonna ask myself, I'm trying to find the value of this, which is x. So the answer is, to what power do I need to raise the base, which is x, the result, and to what power do I need in order to get 5 square root of 5, right? 5 square root of 5. Okay, let's work this out. What I know, I can say like I can write this like 5 to the power of x equal 5 times 5 times what I know the square root of 5 can be reading like an exponent is 5 to the power of 1/2, so that's another way to write the square root of 5. The square root of 5 is like 5 to the power of 1/2. So I just write the square root of 5 another way. So I'm gonna keep working this. Let's go to where there is some space. So if I have to keep on, I will say 5 to the power of 5 equal, remember we had 5 times 5 to the power of 1/2, so I'm gonna just add the exponent. So here I get 1 the power of 1. It's like I have 5 to the power of 1 plus 1/2. This is gonna give me, I'm gonna have like 5 to the power of 1 plus 1 plus 1/2, right? 1 plus 1/2. So this is gonna give, if you see I have 5 to the power of 5, this is gonna give me like 5 to the power of, this is gonna give me 3/3, and that's it. I find the exponent. So the exponent x is 2.5. Remember, every time I'm trying to compute the log of a number, what I'm trying, the log base b of a number, I'm just trying to find the exponent. So the questions, what is the exponent necessary in order to get the value? So in these situations, I was trying to figure out what is the exponent, like to what power do I need to raise 5 in order to get 5 square root of 5. So here they put the resolve equal x. That's why I use x like the exponent, because what I was trying to compute, that was this value, log base 5 of 5 square root of 5. Okay, so since they use x, so I know the result is x. X is the exponent. So what exponent necessary to raise 5 in order to get 5 square root of 5? So the exponent necessary is, like we find it, is like x, we already computed, is like x equal 3 over 2. That's the final result. 3 over 2, excuse me, 3 over 2. Okay, that's the final result. So let's keep on. What about this one? We're just making practice on a logarithm. Log base 9 of x is equal 3 over 2. The base is 9, so what I'm trying to figure out, to what power do I need to raise 9 I know the power here, I know the result. So here I can say 9, since I know the results. See, I can say 9 to the power of 3/3 equal x. Now it's really easy to find x. Then x equal 9 to the power of 3/3. That's the values. Here we have x equal 9 to the power of 3/3. We can let it like that, or if we want, we can try to write x in another way if we want, but that's the final result. Understand, when we try to compute this log base 9 of x, so what I'm trying, the result, here I got the results. So 9 raised to the power of 2/3 equal x. I know the result. That's why I use 3/3, because I know the result. If I didn't know the result, I would say I was trying to figure out the exponent. They give me the result. Remember, the result of a logarithm is an exponent, because every time I'm trying to compute the log base b of a value, I'm trying to find the exponent. The final result is the exponent. So I know the exponent. That's why I use 3. The exponent here is 3/2 equal x. So now that's the final result. I can write it better if I want, since I can say this is like I have I can say this is like I can say this is like 9 times 9, you see what I mean, over 1/2. I can write it like that. So this is gonna give me x 9 times 9 times square root of 9. This is 27. You can do it easily on your calculator. You're gonna get 27. Okay, this is 27. This is easy. Okay, what about this one? The same thing. Understand, every time you try to compute log of a value, while you trying to figure out is an exponent. Here I know the exponent, they give me the result. So I can say 5, the base is 5, right, to the power of -1. I know the exponent, I know the value, huh? Equal x. So equal x. The power, it's like here I say the power necessary to raise 5 in order to get x is -5. So I know x minus 5 to the power of -1 is like, I can be written like this: 1/5 equal x. Okay, that's the final result. You can write it in a decimal value if you want. 1/5. Okay, what about this one? Understand here, log base b of 16. Every time I'm compute the log base of a value, what I'm trying to figure out, the result is the exponent. So I know the result. The result is the exponent. So I can write it like that. The result is the exponent. It's like b to the power of the result, which is 2, equal 16. So now they ask me to find b, since I may try to figure out in my head which is the base. When I raise it to the power of 2, that give me 16. That's 4. So here we can say b equal 4, since 4 times 4 times 4 is 16. The base is 4 here. What about this one? It's the same strategy. Log base 8 of 4. Understand? The result is the exponent. So every time I'm trying to compute the log of a value, I'm trying to figure out the exponent necessary to raise the base in order to get the value 4. So I'm gonna use the same strategy. 8, which is the base, to the power of x equal 4. equal 4. So now what is the value of x when I raise it? That gives me 4. It can be hard sometimes to find. That's why here you can use your calculator if you want. Log base, you can use your calculator. Log base 8, because it's not really easy to find this one. It can be hard, but that's why it's important to sometimes to use your calculator. So here I'm guessing it can be 3.5. Let's say if I have like 2.5, I'm trying to figure out what is it. Let's say if I have like 2 times 2. Okay, I can try to put it like an exponent. I know this can be like 2 times 3x. You see what I mean? This can be like 2 to the power of 3x, since 8 is 2 to the power of 8 is 2 to the power of 3. So I can write this like that, and I can say this is like 2 to the power of 2 or 2. You see my strategy here? So here I can say 3x equal 2. You see, I just use a strategy. So here I can say 3x, excuse me, I can say here 3x, right? Excuse me, 3x equal 2. 3x equal 2, no, x equal 2 over 3. That's the final result. But you know, for this example, you really can log base 8 of 4. You really can try to use your calculator, but not all scientific calculator have these functions of where you can change the base. Some of them have it. But you can go online also. There is some online tool that can help you to compute the logarithm of whatever the base, you know. But here I find it is 2 over 3. But if you have a complicated scientific calculator, you can just change the base and this is gonna give you 2 over 3. Okay. Oh, let's do this final example. Let's do this final example. This is like let's see, I have here like log base b of 8 equal -1. I find the result. Understand, I will always remember when I'm trying to compute log base b, whatever the base of a value, the result I find is the exponent. So since I was asking the questions to what power do I need to raise b in order to have 8, I found the result. I had the result here. So they told me I need to raise it to the power of -3. So I can write it like that. I can say b to the power of -3, you hear me, equal 8. b to the power of -3 equal 8. So here my base here, since this give me like 8, so I know if it was if I use 2 here, it's gonna be like if I was 2 here, it's gonna be if it was 2 here, it's gonna be 8. That's why here the b here is equal to 1/2. Okay, this gives me 1/2. If you have 1/2 raised to the power of -3, you're gonna get 8, since 1/2 is 2 to the power of -1, minus 1 gonna give you to the power of to the power of 3. So b here equal 1/2. That's the value of b. Okay, so here we do different example, and with all those examples we were trying to figure out the log of a value. Remember, when you compute the log base of a value, what you trying to find, an exponent. That's the question. What is the exponent? The result, it's always the exponent. What is the exponent? To raise the base in order to get the value. Okay, so we're gonna make another type of exercise. Since this is take a lot of your time, we're gonna resolve some exercise where we have log and exponential at the same time. That's all for today. See you for my next video.